At NASA, innovation drives our journey
to reach new heights
and reveal the unknown, which will benefit all of humanity.
That work is part of a vital strategy to equip our nation with the technologies for the future.
To inspire a new generation of explorers.
To make the next giant leap for humanity.
NASA innovation spurs economic growth while continuing U.S. leadership in space and breakthroughs in science and technology.
It's such a thrill working for NASA and exploring the universe.
NASA's on a journey to Mars.
This ambitious goal involves everything that we do.
It will transform technology and define our generation.
Robotic explorers are paving the way to Mars.
We're learning enormous amounts about the surface of Mars daily.
In the coming years, another lander and a new rover will discover even more.
We're working hard on the solvable challenges of sending humanity to the red planet for the first time.
That includes innovation in propulsion,
radiation shielding, and landing large payloads.
The Orion spacecraft, which will carry astronauts deeper into the solar system than ever before, has achieved a major milestone with its first spaceflight.
Soon, it will fly on the most powerful rocket ever built.
The Space Launch System, which has moved from concept to development.
We're advancing the journey to Mars through progress on the asteroid redirect mission.
To send people to an asteroid, use what we learn from that mission, and then someday send people to Mars.
NASA's mission to an asteroid will test new capabilities in the proving ground of deep space.
Our journey to Mars is also unfolding right now
aboard the International Space Station.
The station facilitates growth in a robust commercial market
in low Earth orbit for scientific research,
technology development,
and for transporting both people and cargo.
Together, we're operating experiments off Earth, for Earth, that are helping us learn how to improve life for humans living both off and on our planet.
The station is our outpost on the edge of deep space,
where we are advancing human and robotic exploration of farther destinations.
American companies are developing systems in which astronauts soon will travel from the United States to low Earth orbit.
Commercial partnerships are helping us take the next giant leap
by developing new ways of reaching space,
creating jobs, and enabling NASA to focus on the cutting-edge technologies for future missions.
Technology drives exploration.
And at NASA, transformative capabilities and cutting-edge technologies are being developed, tested, and flown today.
Our impressive set of science missions takes us on a journey of discovery.
To understand our home planet and its sun,
search for life beyond, and explore the origins and future of the universe.
The most important planet that we study is the one on which we live.
As a leader in Earth science, NASA's constantly expanding view of our planet from space is helping us understand our home planet and its changes.
Air travel fuels our modern world.
And NASA is committed to transforming aviation.
We're dramatically reducing air traffic's environmental impact, maintaining safety in more crowded skies,
and paving the way towards revolutionary aircraft technology.
NASA is with you when you fly. And taking you on the journey to Mars.
Everything NASA does is improving life on Earth.
Raises the bar of human achievement.
Making tomorrow's discoveries today.
We're America's National Aeronautics and Space Administration.
And every day we're helping to reach new heights,
reveal the unknown,
and benefit all humanity.
Really cool stuff, isn't it? Well, good afternoon. It's my pleasure to welcome you to the Kennedy Space Center. I'd like to thank Administrator Bolden for selecting KSC to deliver the State of NASA address. We're honored to have this unique event here in the Neil Armstrong Operations and Checkout Building High Bay, one of the many examples of the transformation that is taking place here at the Kennedy Space Center. For the past 4 years, we've been hard at work redefining and repositioning Kennedy for the future. Look no further than the spacecraft behind me to see our progress. These vehicles represent the essence of the future of human spaceflight. And all 3 crew systems will be processed and launched right here along the Space Coast. We've made the initial transition to become a true multi-user launch complex for both government and commercial customers while embarking on NASA's new deep space exploration plans. We're solidifying our position as the world's preeminent spaceport, and a dynamic infrastructure is taking place here, one that will host many kinds of spacecraft and rockets. Our Ground Systems Development and Operations program is leading this modernization effort to transform KSC into a 21st century spaceport with capabilities to launch spacecraft built and designed by both NASA and private industry. The $2.5 billion budget proposal for the Kennedy Space Center further cements our path forward and confirms that Kennedy is headed in the right direction in support of NASA's exploration, science, and human spaceflight missions, as well as enabling further commercial space operations from here on the Space Coast. This is truly an exciting time for the Kennedy Space Center, for NASA, and for our country. And it gives me great honor and pleasure to introduce our administrator, Charlie Bolden.
Thank you all very much. And thank you, Bob, very much. You know, it's great to be back here at KSC. It's always good to be here, particularly this close to the crew quarters, and it's sort of reminiscent for me of some pretty good times down here. You know, it is here that so many giant leaps have been made, but what's really important is that it is here that many of our future dreams will be made to come true. And so that is sort of the reason we decided that we wanted to come here to the Kennedy Space Center to talk to our entire NASA family. Now, I thought about Glendale, the stadium where we could pack in all 18,000 employees, but it was busy. And we couldn't get all of this set up in time. You know, they had to get everything out from everything last night, so we're here, and I'm talking to the majority of our employees via the marvel of television and everything else. But nonetheless, my message today is for all of you in the NASA family. And since I see some of our contractor friends here, you're in the NASA family, and hopefully that will be obvious as I go through my remarks. You know, it was just a few years ago, 2010 to be exact, that President Obama stood here in the Armstrong Operations and Checkout Building and committed us to a journey to Mars, beginning with an unprecedented mission to send astronauts to an asteroid as part of a stepping stone approach to reach the red planet. Thanks to the hard work of our NASA team and the work of our contractor, academic, and entrepreneurial partners all across America, we've made a lot of progress on that journey. This includes progress in integrating all of our work in a structured roadmap that is leading us to breakthroughs in new advanced technologies, driving us to new destinations, and generating the inspiration on which future generations will thrive. Just behind me, and Bob has already pointed them out, are some tangible examples of our progress. And that, for those of you sitting here in the audience, I think you can feel it. For those who are looking on, hopefully the cameras are good enough that you can sense it, because it's really important that you recognize that these vehicles, they're not things on paper anymore. This is tangible evidence of all the work that you all have been doing for a number of years now. The Orion spacecraft, which recently performed a near-flawless flight test on its first journey to space, is being taken apart right now so it can reveal its secrets about that amazing flight. And I am thankful to the crew working Orion, all the Lockheed Martin folk and everybody else who managed to stick enough of it back together so we could have it here with us. But for people who may not work down here, I recognize the fact that it was really taken apart and then put back together so we could have it here, and that's really important. What we learn will prepare us for its next launch aboard our Space Launch System rocket, or the SLS. and its future with astronauts aboard, exploring farther into our solar system than ever before. Thanks to the grit, determination, and American ingenuity, we've returned cargo resupply missions to the United States, insourcing these jobs and creating a whole new private market in low Earth orbit. Now, U.S. companies, large and small, are developing the new systems in which our astronauts soon will travel from right here on the Space Coast in Florida to low Earth orbit. This initiative, where we hand off low Earth orbit transportation to the private sector, is absolutely critical to our journey to Mars. Absolutely critical to the journey to Mars. The Boeing CST-100 mock-up behind me is representative of the flight vehicle that is a prime example of how American aerospace industry is rising to the challenge of increasing crew safety while bringing down the cost of space travel. The CST-100's well-lit structure is innovative engineering that makes the spacecraft reusable up to 10 times. This pressure dome has no wells, which allows for a short turnaround time between flights, increases simplicity of production, and drives down costs. SpaceX also is working on a Crew Dragon to complement the successful cargo capsule that has now been regularly delivering cargo and science experiments to the International Space Station for more than 2 years. The Dragon cargo module behind me flew SpaceX's first mission to the ISS, becoming the first spacecraft produced by a private entity to be launched into space, rendezvous with, and be berthed to an orbiting outpost, and most importantly, to deorbit and land intact back here on Earth. That spacecraft. A version of the Crew Dragon is being prepped for shipment and is set to arrive just down the road at Cape Canaveral Air Force Station in the next couple weeks for an upcoming pad abort test flight. Both SpaceX and Boeing have set up operations here on the Space Coast, bringing jobs, energy, and excitement about the future with them. To further advance these plans and keep us moving on forward in our journey to Mars, President Obama today is proposing an FY 2016 budget of $18.5 billion for NASA. $18.5 billion for us, building on the significant investments the administration has made in America's space program over the last 6 years. That's $500 million increase over last year's enacted budget. The enacted budget, $500 million over last year's enacted budget. And it's a clear vote of confidence to you, the employees of NASA, and the ambitious exploration program you're executing. Your work is vital to the strategy to equip our nation with the new advanced manufacturing and space technologies for the future, and to inspire a new generation of explorers to make the next giant leaps in human experience. NASA is firmly on a journey to Mars. Make no mistake, this journey will help guide and define our generation. This year, we celebrate 50 years since Edward White left his Gemini capsule to become America's first spacewalker. It was only a few years later that we landed humans on the moon. And not too long after that, the United States became the first, and still, the only nation to successfully land a spacecraft on Mars. Our incredible 30-year space shuttle era followed from the early 80s through July 2011, during which the science community saw the deployment of 3 of the 4 great observatories deployed from the shuttle during the decade of the 90s. The Hubble Space Telescope in April 1990, the Compton Gamma Ray Observatory in April of 91, and the Chandra X-ray Observatory in July of 99, contributing to a golden age of planetary and astrophysics exploration and discovery. It was through the Space Shuttle program that NASA opened spaceflight to many, like me, who had previously had no chance of flying, bringing diversity in our crews to women, minorities, and astronauts of many other partner nations. To me, that's perhaps its greatest legacy. Using shuttle as our transportation for our astronaut construction crews, we then spearheaded assembly of the International Space Station, in which humans have now lived continuously for more than 14 years. For some of you who used to work down there in the ISS production facility, remember in the days when, because we couldn't put it all together, we said this will never work? Or for those of you at JSC who were around the crew office or in engineering like me saying, we'll never be able to do this, it's too many EVAs, it's too this, too that, too everything. I'm looking at Mike, you were there. Examples of where we have been, but examples of your resilience and your belief in the future that shows what we can do. Over the past 6 years, we've taken the most concrete steps ever to advance a human mission to Mars. This journey to Mars, indeed our entire path to the future, starts right now, right here on Earth. Our commercial crew work, for example, is headquartered here at Kennedy, but encompasses efforts in 37 states, from Nevada to Montana, to Kansas, Wisconsin, New Jersey, and North Carolina. Whether you're working in a family-run composites factory mill in Pennsylvania, as those who are working in a place called Bally Mills in Bally, Pennsylvania, where I was privileged to visit before the Christmas holidays. You're from Bally? Pennsylvania. Anybody else from Pennsylvania? Here? I know there are people on the net from Pennsylvania, but Bally Mills, a small company of 300 employees, mostly women, started out making ribbons for military uniforms, and today making space-age textiles and the like that are on our spacecraft. You know, it's whether you're working in that type of business, developing the next generation Mars rover in California, from the Ohio Space Corridor to the Mid-Atlantic Regional Spaceport in Virginia. You're all a part of the journey. Right now in Mississippi, at our Stennis Space Center, and folk down at Stennis, I know what you're saying. Hope he'll say, nothing goes to space until it goes through Mississippi. So if you were waiting for me to say that, I said it. And people down in Mississippi understand that. You all here, you may not. But Bob Cabana will tell you, if it's got an engine on it, nothing goes to space without going through Mississippi. We just tested the RS-25 engines from the space shuttle, 4 of which will power our new space launch system to carry Orion on future missions to deep space. In just a few weeks, the solid rocket booster for that rocket will be fired up in Utah. Students from the Governor's School of Science and Technology in Hampton, Virginia, winners of our Lockheed Martin NASA Exploration Design Challenge, flew radiation shielding on experiments on Orion, and continue to use our commercial partners to send experiments to the station, nurturing not only new discoveries, but the hands-on experience of a new generation hungry to make space their own. This summer, NASA plans to once again test our low-density supersonic decelerator off the coast of Hawaii to continue proving in flight the new technologies critical for landing larger payloads on the surface of the red planet. We know that technology drives exploration and our journey to Mars. We also will continue to develop advanced solar electric propulsion systems needed for the asteroid redirect mission and other deep space missions, and to make advances in the atomic clocks and green propellants that will guide and power our future missions. Landing on an asteroid, traveling through space, or retrieving a piece of it requires advanced autonomous robotics and guidance and control technologies. These NASA-developed technologies will be applicable to commercial satellite servicing, future exploration, resource extracting, mining, in situ resource utilization, and planetary sample return. The asteroid mission will also demonstrate advanced high-power solar electric propulsion, or SEP, critical for future NASA and commercial uses. The mission will test asteroid deflection techniques and may provide information to inform future work to help us protect our own home planet. We have identified several asteroids that could be good candidates and will make a decision soon on a capture option. As we advance our journey to Mars, we're also focusing here on Earth on making aviation greener, quieter, and more efficient. Every U.S. aircraft, and U.S. Air Traffic Control Tower has NASA-developed technology on board. NASA scientists and engineers are working on new composite materials that will make future air and spacecraft lighter and more durable. NASA is with you when you fly. And we're committed to transforming aviation by dramatically reducing its environmental impact, maintaining safety in more crowded skies, and paving the way toward revolutionary aircraft shapes and propulsion systems. As we all know, the most important planet we study is the one on which we live, Earth. The reality is, our planet is changing. And the data continues to prove this, but we're on it. NASA is a leader in Earth and climate science, and our constantly expanding view of our planet from space is helping us understand Earth and its changes. When natural disasters impact us, the space station and NASA satellites are there to help make time-critical observations and aid in recovery. In the last 12 months, we've launched 5 Earth science missions. 5 in the last 12 months. The latest of which, Soil Moisture Active Passive, or SMAP, was launched just this past Saturday. These missions are studying such diverse things as ocean winds, components of our atmosphere such as clouds and aerosols, and precipitation on a global scale. SMAP will give us, for the first time ever, a picture of soil moisture on a global level. The mission will help improve climate and weather forecasts and allow scientists to monitor droughts and better predict flooding caused by severe rainfall and snowmelt. SMAP data will allow nations to better forecast crop yields and bolster early warning systems. The Airborne Snow Observatory uses instruments aboard aircraft to tell again, for the first time ever, how much water is stored in the mountain snowpack and how that changes from week to week. This is critical to helping evaluate and plan strategies to combat the intense drought plaguing California, Colorado, and many other southwestern states, and help protect their businesses and communities. NASA is leading the way in understanding local, regional, and global water cycles, information critical to understanding our environment and supporting our economy and national security. The technologies we develop to explore space have practical applications right here on Earth. One example is the shock absorbers used during space shuttle launches that are now being used to brace buildings during earthquakes, preventing damage and saving lives. Or a NASA simplified bacteria test being used to monitor water quality in rural communities around the world. And cabin pressure monitors that alert pilots when oxygen levels are approaching dangerously low levels in their aircraft. As we strive to achieve the dream of sending humans to Mars, it's important to remember we're already there. For 40 years, increasingly advanced robotic explorers have studied the red planet. This has dramatically increased our scientific knowledge and helped pave the way for astronauts to travel there. Our latest Mars spacecraft, MAVEN, arrived last September to study the upper atmosphere and joined a fleet of orbiters and rovers on the surface. Next year, we'll send the InSight lander to study the planet's core. In 2020, a new rover building on the incredible success of Curiosity will help us prepare for human arrival at Mars and, for the first time ever, will cache a sample for later return to Earth. Mars is a key destination, but it's only one point on our journey of discovery. It's a journey across and out of our solar system to the farthest reaches of the universe and the frontier of the human capacity to explore. I was privileged 25 years ago this April to pilot the Space Shuttle Discovery's STS-31 mission, during which we deployed a Hubble Space Telescope. Hubble is still doing absolutely amazing science, and the last textbook that will have to be rewritten because of its discoveries, it hasn't even been drafted yet. In just 3 years, we'll launch the James Webb Space Telescope, Hubble's successor, and continue to reveal the unknown with the largest observatory ever put in space. That amazing telescope is taking shape right now in suburban Maryland, where the mirrors have arrived and the heart of the telescope that holds its instruments successfully completed a nearly 4-month test in a cryogenic thermal vacuum chamber. After nearly 9 years and 3 billion miles of travel, New Horizons spacecraft was awakened last month in preparation for its arrival in the Pluto system this coming July. Right now, Dawn is approaching the dwarf planet Ceres. Juno is speeding toward Jupiter, where it will not only send back unprecedented data from a first-ever polar orbit of our giant neighbor, it will demonstrate how solar power can work at great distances from the sun. Looking to the future, we're planning a mission to explore Jupiter's fascinating moon, Europa, selecting instruments this spring and moving toward the next phase of our work. The Kepler mission continues to discover new planets outside our own solar system. It has confirmed more than 1,000 planets, some of which could be rocky, like our own Earth. The Solar Dynamics Observatory just took its 100 millionth image of the sun. And in dozens of other astrophysics and heliophysics missions, the data streaming back to us is bathing us in information through which scientists will sort, decipher, and make discoveries for years to come. Our journey of discovery has only just begun. Together, humans and robots will pioneer Mars and the solar system. In fact, they already work closely together on board the space station. As the President said in his State of the Union speech just 2 weeks ago, and I quote, "We're pushing out into the solar system not just to visit, but to stay," unquote. Next month, we launch astronaut Scott Kelly and his Russian counterpart, Mikhail Kornienko, on a 1-year mission aboard the station to learn more about how to live and work in space for the long term. We'll compare his vital signs to those of his twin brother Mark back here on Earth in a first-ever experiment using identical twins to learn more about the effects of living in space. So as I stand before you today, in front of these very, very tangible examples of our progress and our future, I can unequivocally say that the state of NASA is strong. Our newest rocket, the Space Launch System, has moved from formulation to development, something no other exploration class vehicle has achieved since the agency built the Space Shuttle. And right here at the Kennedy Space Center, the ground systems team has also moved from formulation to development, making steady progress toward modernizing and advancing our ground systems to be ready to launch the SLS. We have 2 commercial providers bringing cargo and research to the space station, something that would have been science fiction just a few years ago is now fact. This success and the rapid progress our commercial crew providers are making validate our faith and investment in commercial space and American industry. Science maintains its intense grip on the world's imagination in the handful of examples I've mentioned, and those are just a few. There are dozens more. None of this happens by accident. We outlined a vision. We got bipartisan support for it, and then you, the most talented workforce on or off the planet, go execute the plan. That's how we did it. Some have said that NASA's adrift. Well, if you look at everything I've talked about today, at the spacecraft of the future behind me, and the concrete plans in development for human and robotic exploration in cislunar space and beyond, if you visit our various NASA and commercial manufacturing facilities where work is ongoing for the future, such as Michoud, here at KSC, in Utah, Texas, California, countless other places. If you travel the world as I regularly do, and you see the enthusiasm I see for NASA every single place I go, or you interact, as I do regularly, with the tens of thousands of students around the world, from elementary through graduate school, who are excited about the dream of one day traveling to space and visiting Mars, I think you'll come to a totally different conclusion. That the idea we're adrift is an empty hook trying to catch yesterday's fish. I couldn't be more, they told me that you guys would understand that down here at the Cape. None of you are fishermen. I see some heads going like some of you are. You understood it? All right. I'm going to skip over that, all right? I couldn't be more excited about the future. I hope you realize that. And I say this over and over and over again. I could not be more excited about our future. We're making steady progress and continuing to reach for new heights. We're making our mark on history. And along the way, we're inspiring a whole new generation of scientists, engineers, and astronauts. That's why we're dedicated to STEM education and broadening the pipeline to develop the leaders of the future. That's why we've been inviting citizen scientists, makers, and innovators from across America and sometimes around the world to share their best ideas through prizes and challenges. I want every single American to feel the pride that all of us who work at NASA have for our space programs. What do I tell you all every time I get together with you? Stick your chest out. When somebody asks you where you work, I work for NASA. I work at the Kennedy Space Center, or Stennis, or Armstrong, or Michoud, or Goddard, or Glenn. I'll stop because I'll get in trouble if I forget one. But I want every American to feel that same sense of pride that you and I feel whenever we talk about the work that we do day in and day out. What we've accomplished in the past 6 years and what we're going to do in the years ahead, that's the best way I know to achieve our dreams. Tell people what we're going to do, plan it, and then go do it. And you all have done that incredibly well over the past 6 years. Just stop and think about it. I mean, think about where we are today compared to where we were 6 years ago. That's really, really, really important. And we need to share that with the American taxpayer so that they too can stick their chests out the same way we do when we brag about our systems. NASA is an incredible investment to our nation because what we do not only uncovers new knowledge, it raises the bar of human achievement. People everywhere are attracted to what we do. because exploration embodies our values as a nation: resilience, hope, overcoming the challenges faced. As the best place to work in government, and don't forget that, 3 years running now, as the best place to work in government, we all share a willingness to learn from our mistakes so that we can transform the impossible into the possible. That's what we do. Because of the dedication and determination of each and every one of you in our NASA family, America's space program is not just alive, it's thriving. Together with our commercial and international partners, academia, and entrepreneurs, we're launching the future. With the continued support of the administration, the Congress, and the American people, we'll all get there together. Thank you so very, very much.